All right. Let's try this. Let's try this. Okay, let's try this. All right, let's try some local. Go. Let's try some Go lang. So I forgot the last time I used Go, so the syntax and the semantics are fairly very forgotten, but let's try. So wait, let me just set up the. I don't know how to properly set up this. Let's see. The background music is well heard, but not enough to be a cacophony with my voiceover. Yeah, so I don't know how to test this kind of setup. So yeah, let's proceed. So basically, when I'm learning a language, what I like to do is go in this website, learn, go in XY minutes. So yeah. So basically, the concept is the same, like programming is the same. So this is an imperative or procedural language, however you want to call it. And so this is similar to C, with the exception of the syntax. But the concepts, the core concepts, the fundamentals should be the same. Like you have the for loop, you have the if statements, you have the function. So yeah, so if you know programming fundamentally, using a new language should not be difficult. It should be very easy, unless you're that is in the case of the same C style family. But if you're going to write like Lisp like family, then that's different one, or Haskell, something like that. So yeah. So basically, what I like to do is go over my Leetcode code, the past the solve easy ones that I've done with let's say I have here Python. So let's try doing the same solution but in Go, so I can be more familiar. So label X defined and not used. So that is weird because we use the X here. So I believe what we to declare a variable, so you do this. Okay. And okay, so we need the var keyword here and no uh colon for the type like in Python. So honestly, this is uh very weird because the creator of Go, or I believe Rob Pike, and I forgot who's the other guy. So they're like the creator of C as well. So my history might be wrong, but yeah, something like that. So it's weird that in C you do int and then the type, and then for this one you do the variable and then the type. But coming from C or in C++, I can see the usefulness of that, because in C and C++ it can be ambiguous if you have a very long type declaration. So and then with pointers and stuff, so it can be more difficult. So yeah, so not much. I believe you can't do this with Go. Yeah. So this is my style of programming. Like the braces are in the new line, but in Go you can't do that because Go is very simple in the sense that its simplicity is enforced. Right, yeah. So if we do it like that, you can see it's a very simple thing. Like right, yeah, so it should not give us any problem. Like in that, like that's a very minor stuff, but as you can see, its simplicity is enforced. So the enforcement of its simplicity results in a better simplicity, if you get that. It's very confusing, but yeah. So yeah, so let's try submitting this one. So let's see if this works. So the look at that. Look at that. Look at how different Go is with Python. Look at this. Same solution, same code, like same logic, same everything. The runtime for Go is serious. Is practically non-existent. The performance cost is practically non-existent. And then the memory. Look at this. Look at the difference. This is why I like a strong statically typed language compared to Python. I'm so used to Python that I forgot that why I hated or disliked Python in the first place. Yeah, well, before that is. Okay, so I don't think I like to play any more music in the background. So let's just focus on coding. Okay, so let's see if in the extension I'm using Leethub to uh properly work. So I changed my Python solution to Go. Yeah, okay, so we have this here. So but let's see if the Python code uh was removed. But yeah, I don't think it's removed. I think it just wrote a new file. So this one is the power of 4. So the power of 4. Okay, so this is good. Yeah, so this is good. So we have the Python and then the Go file as is. Okay, so let's try, let's try doing the same one in a different language. Na Rust. Na So this is Python too. So with C, yeah, that I don't like to go back to C and C++. I was planning initially on upgrading my thesis, our thesis software CodeNet. So this one, so it's a very, I think, complex program. Done within 2 months, I think, 1 to 2 months for thesis. So you can see the screenshots here, but let's go here and let's go to modules. Okay, so you can see, and the images are not loading again. I wonder why. So this is weird. Why is not loading? I think it's a problem with, yeah, I think it's a problem with, let's try not using the, how do you call this? The new unique tab. Yeah, it's still not loading. This is weird. So the link is pointing to HIO, but I think my browser blocks it. So, yeah, but I've set it to no blocking. So anyway, we have pictures. Where's that? Yeah, we have pictures here. So if we will look at the media, let's go to uh here we have like command palette, and then they can basically modern software. Then we have node creation sample. Yeah, and then let's try the running. Yeah, so okay, not that one. Sample branching. Yeah, here we go. So yeah, okay, so this is our thesis. Oh, wow. I did not expect this. I totally forgot. I was planning to live stream enhancing this software to support like showing the flow of the code, right? But there you go. I've already implemented that before. You can see uh this means that the with this code the branching goes to the false one, right? So it goes to the false one, not the true one because of the coloring. So I was practically about to do this. Yeah, so here 32 is equal to 64, so that false. So it went to the false path. Okay. So I was about to implement that and then there you go. Anyway, another thought that I had is to so basically these nodes this visual programming can be transpiled into originally I was planning C++ plus plus and Java. Yeah. Java, yeah. Yeah, that garbage. And but the like one of the purpose of this thesis is to create a portable one, right? So there's no installation. And you can't do that with C++ and Java because you have to install a lot of dependencies, especially with Java, the virtual machine. So I skip that. And C++, yeah, that thing also you have to like have the GCC or mean GW or the Microsoft Visual Studio C++ extension, right? So I went for Tiny C compiler by Favlard. So you can see here, this can be, okay, error loading page, why? Okay, why? Oh, come on. Give me the picture. Yeah, no, never mind. This is a picture why I show that. Uh, okay, so wow. So yeah, this is the this is the like transpiled C code. As you can see, it works, but it's not clean and it's not written properly. Like we have parentheses here, so we can exclude one. So and then we have an empty else. Yeah, so there's no optimization or there's no optimization pass. So it just compiles the code or transpiles the code from at runtime without any pass. So yeah. So I was planning to also support Python, but uh, maybe for other languages I have to allow using the already installed Python, right? So the program can work as is without Python, but if you want to use Python or other language, you want to transpile to that language, you have to install the other language environment or toolkit in your machine, and then you just set up like the path to the executable, something like that. So I was planning that, and then uh, and then I reviewed the code. So here I have the transpiler code. So as you can see, I can't recall anything anymore about this one. Because I've written this hastily because of the tight deadline with this is like 1 to 2 months of development only, and then I have a lot to cover. So you can see we have switching here on what kind of node is the current one or the next one. So I'm not even sure if I implemented linked list with this one or just a nested. So, oh yeah, just use a vector, an array. So yeah. Okay, so I don't think I can go back to this one anymore, but I think I can just like basically I already have the thing set up. So if I see a string methods, oh wait, no, this one is uh I don't know why I implemented this. Oh, this I think these are for examples. I don't know. Okay, so basically if we have a yeah, we have a casting. Yeah, these are templates, yeah. So if we look for uh now I really don't understand. Okay, so where's the code that does the oh yeah, I remember these are needed by I think by yeah. Oh yeah, this one is for the when you run the code, so it launches a sub process, a command prompt, and then you can ask for input, right? You can ask for input. So basically I implemented basic functions for that. So yeah. Yeah, for this one for the prompt. Yeah. So so this is very uh not good. Yeah. So and then okay, I think this is what I'm looking for. Node to code. Yeah, that's a very good node to code. Yeah. So I think we can just have an interface. Like you can just implement this and then instead of let's look at the implementation. So this is supposed to be a Go stream, but yeah, let's just talk a bunch. So yeah, so if we get a bool type and then the like this is the input and then the output like the target node is an integer, we do this like this is translating so basically we can just replace this with the Python code like for example yeah we have here indent, we increase the indentation, yeah, and then here this is for the type. Yeah, so if we get the slot of a bool or an integer, we define those type. Yeah, so for Python, we're just basically going to remove this, or we're just going to return an empty string, but we're going to use this interface, or just redefine or something. I don't know what's the term for it. And then, yeah, this one is for printing, right? So yeah, so yeah, maybe this is doable. Maybe this is doable for yeah, we have dynamic cast. Okay, so okay, so if we're going to get a string, yeah. So basically we're just going to this one. This is an in declaration, variable declaration. So for Python or code, we're just going to move change this and then it should work. Yeah, it should work. Man, the code format I did. Wow, this is very not me today. Okay, yeah. So maybe it up to 1070 lines of code. Um this yeah. This would be easier if I had the time to translate the the visual nodes into an abstract syntax tree, ASP. Yeah, I look, I look at about that before, but that's another layer in the development, so I opt out of that. So basically, but this is basically my implementation is kind of like that. So basically, instead of an abstract syntax tree, I think I just use wait no where is that? Yeah, simulation is for the loops. Yeah, I forgot. I think it's in transpiler. Yeah, this yeah. So it is a nested list. It is a nested list. So this one is for the sequence, and then then we have I don't know. Yeah. So basically I just stored into different. So basically not a tree or like a tree, but like trees with different. root nodes. Anyway, we're getting off topic. So let's go back to programming in Go. And okay, so oh wow, we have viewers. Okay, so if you have any question, just feel free to ask in the comment, and then hopefully I can see that later. Okay, so let's proceed to the next problem. So basically, I'm just doing Leetcode like once a day if I can or something. So let's try another one that is already solved. So basically, we're not solving anything new. We're just like rewriting into Go. Yeah, so let's try this one. So for return in indices of the two numbers which they add up to there. Okay, so this is a very easy problem because we only have exactly one solution. So I think the medium problem of this one is with constraint, like return the minimum, like the minimum in indices, something. So for this one, we only have a single. So nested loop will do. Okay. So yes. So but this is not n squared because we have nested loop, but the second loop does not go from the whole n number of arrays, but we go from the I plus one. So it's log n. So n times log n, or 2 log n, or wait, no. Yeah, n log n space time. So let's try doing this in Go. So let me just review. Okay, so for Go, so we're just going to go loop. So let's see where is the loop here. I need to check the syntax for for loop. Yeah, there you go. Okay, so this is an infinite loop. Yeah, so basically the iterator, the condition, and then the increment, the post condition actually. This can be anything aside from increment. So yeah, basically a statement. Yeah. Okay, so then we also have range. Okay, so for range, this is for a map, right? But we don't have a map. We only have an array. So okay, so this one works because okay, so we have integer. So this is confusing, right? So this is an array of integer, and then we have a target. So basically what we want to do is we can do this loop. Okay, so for this one, variable declaring for, and if our, I remember vaguely something about variables, local variables in for loop, in Go's for loop body, that there's a catch, like there's a problem with shadowing or something. Yeah, but let's try this. But so actually we just need the index. Okay, so let's do for I. So we can do I. Can we do I int 1 or 0? So instead of, so this is a shorthand if you don't want to put the type, like you just want to implicitly, or for the compiler to infer that type. But if we don't want this, yeah, I think we can do this for now. Okay, so for now, and then we have the condition like I less than. Okay, how do we get the length of the nums? We need to get the length of the nums. So, length. So, length, len, How do we get the length of the list? There's no length or length. Size, maybe? Size. Okay, so we don't. Okay, so let's go length of array. Okay, let's check for Golang array length. I see. So yeah, in Go, just like in C, there's the like you can declare it fixed size at compile time. Oh, you have the len keyword. What? But is why is that not in the doc? Okay, anyway, so the length. Let's try storing that into another variable. So var like L will be the length, so length of the nums. So the semicolon is optional. So L, then I plus plus. Okay, so then we have another one for J, int I plus 1, and then J less than L, and then J plus plus. Okay, so and then let's do if the num sub I plus num sub J okay is equal to the target, then we return the slice, or let's just return the a tuple array list. Yeah, so a slice. I'm not sure if you call this a slice in Go, but anyway, so if there is no okay, only one valid answer exists. Yeah, so we can be sure that the answer exists. So let's try running this. I'm not sure if this works, but it should be. It should, because okay, so it doesn't work. Bar declaration not allowed in for initializer. Okay, so maybe we can remove that. Let's try again. So this is just me, like I know we can just do the where's the for loop again? For yeah. I know we can just do this, but I want to learn what's the other way of writing this. Oh yeah, I forgot the equal sign. Maybe we can do this. So this just me exploring the like the semantics of the Golang language, or the Go language. Golang language is very redundant. Yeah, I guess it no, yeah. Unexpected int. Okay, so it doesn't, so you can only declare variable the iterator variable like this. Okay, I see. Okay, so now we know. I was hoping there's we can do Odin language in this Leetcode, but let's wait for for Odin to gain more traction. For maybe Leetcode can support that. That would be awesome. Okay, so let's do the I guess walrus operator. That's what it is called in Python. All right. Okay, so expecting. Okay, so we have a oh. All right, stupid Python muscle memory. Okay, so we don't use colon for the conditions. Okay, so let's try if we can this not write. Okay, so we do have to write. Okay, so we do have to write, even if the body is a single function or a single line of code, we still have to write the opening and closing braces. Parent, the unexpected comma. Huh. So how do we do return? Oh, I think we have to declare it like this, and then this. like this. So yeah, let's try this one. If not, let's go long return list. I forgot I should not call it list missing return, but we have return here because it's not called list in Golang. In in wait, okay. In languages that are not for beginners like Golang, we don't say list. Okay? We say array because list are for kids. Okay. Yeah, to we have to say the type. Oh, no, we have to declare the size. You have to declare the size. Okay, so I think it's okay. Yeah, no, not this one. I just want to know how to return array tour of Go. Let's go with the official documentation. More types. Okay. No, the ones. Uh, okay, where's the basics? Yeah, basics. Let's go to arrays, uh, methods, and functions. Let's go to functions. Maybe they have functions documented. Slices. Yeah, no, we don't want slices. Okay. Function. Give me function. Where is the function? Function values, function closures. No. So basically not here. Tour of Go. Return array. Go array with examples. No. More efficiently. Let's worry about returning array efficiently later. Okay, let's just learn how to return a simple array. So I don't. Okay, so no. Return. Yeah, this should work. This is the syntax that we use. This is the syntax that we used, right? So we have return and then the integer and then the contents, right? Right. Uh, so it doesn't like that. Let's go with the goal. Maybe we're being too the get started, yeah. So I'm pretty disappointed with this one. I thought that will be covered here. So but maybe I'm just not looking correctly. So let's okay, so we can have a name return. Yeah. So this is dangerous. Like I don't see the usefulness of this feature, right? So you can this is the return part, and then you can have a name for the return value, and then once you declare that, you can just return, and then it's implicit. Okay, so I'm not a fan of doing things implicitly. As much as possible, let's do that. Let's be explicit with the code. Okay. So this just returns simple values, but what we want is, yeah, so no, not much there. So maybe by example or take a tour. Yeah, like take a tour. Wait, this is what we opened earlier. Go. Documentation. Let's go to documentation and getting started with generics. No. A tour of Go. Yeah, no. Oh, fuzzing. Yeah, no, no. Let's go to getting started. Write more code. Probably create a Go module. Okay, so no, let's skip that. For other tutorials, see this one. So basically, we just oh maybe I know just that's just a syntax highlighting. That's type. Okay, I see. The return type is has no fixed size, so you can't return a two there, right? So the type of this, the return type must match the actual value that we're returning. But we have a missing return, so that's what I don't understand. We have a returner. Maybe the Go compiler or the Go piler thought Go Go compiler. Maybe the Go piler wants us to be explicit as well. Maybe add a return here like something null or nil. There you go. Yeah. Okay. So that's yeah. So that got us for a while, but I understand the usefulness of that enforced semantics. Yeah. So okay. Yeah. So maybe because this might fail and this one might never reach, so we have to be explicit that we return nil. So for the callee of this function, this nil can be handled correctly. Okay, so let's submit it. And as you can see, I have a lot of Pythons. I'm pretty sure that uh, I did this for the syncing, or I don't know. Okay, again, compare Python with Go. Look at this. Look at this. This is why for backend, you don't use Python. Okay? For backend, don't ever use Python. And that's a lesson. Python is slow, Python is bloated. Maybe for scripts, for basic tools, I use Python for basic scripts like uh okay, so let's go uh on the side for now. Okay, so for example, in my game project, I think it's going home, yeah, or remembering home, yeah. Okay, so okay, there you go. So previously, I'm using Bash. Okay, so I'm a Linux guy. I like to write stuff in Bash. Okay, so but when I got more experience with Python, I rewrote my build script from Bash, which is like won't be easy to run on Windows. So I wrote one in Python and it's easier to write, it's easier to enhance, it's easier to debug, unlike a Bash script. So as you can see, the script is not that flexible because it's written and it's written tailored for this project. So if you want to apply it to another project, you might do more modification, more patches. But yeah, so 165 lines of code, it gets the job done. So previously, I'm not sure where how can I find the previous bash script, but maybe it's here. Okay, so yeah, go check out my game going home. It's free, the original version, but the latest release is not. Yeah, so Man, my internet is weird. Okay, so restructure project, I think. Yeah, I think it's in restructure project. I moved from a bash script to the Python script. Let's see if we can find it here. Okay, now I still don't know where it. Okay, anyway, that's what I did. Okay, so Python has its usefulness. Python is very easy to write. It's very easy to learn. It has a lot of it has a large ecosystem. You have a lot of package just to do anything what you want, like JavaScript, but Python should not be used for backend because it's slow. It's terribly slow, especially if you have a big backend. Don't use Python. Okay, don't use Python. I know Python is easy. Python is for beginners, but don't use Python. Use a language suited for intense processing like the back end. Okay, so compare the same logic code from written in Python to Golang. You can see a very big difference. Okay, in terms of memory and runtime. So if you want to if you want to save cost with your microservices and stupid AWS stuff, then this will save you more money because you can accomplish more things faster. So less time use is less money spent on AWS. Okay, so look at this. Okay. Anyway, enough with the rant and let's move on. So let's try add two numbers. So this one is medium. So this one is medium. I do hope I can make the comments pop out. Okay, there you go. We can pop out the comments, but uh I would like to show this in the stream, but there's no comment yet. So maybe a block. Okay, so anyone can comment. Okay, yeah. Okay, I'll just wait for the comment for any comment up here. Okay, so adding two numbers. So this one is a linked list. So yeah, so this is a good thing. Uh, wait, twice. I solved it in C sharp. Really? Wait, when did I do that? Oh, I don't use C sharp. I have eyeglasses. I don't see sharp. Okay, I have I have poor eyesight, so I don't see sharp. But and C sharp is basically Java with more clothes. So yeah. Okay, so this is this is not recent, and I yeah, this is not sync with my Leetcode repository. So number two, so you can see there's no rep. Yeah, we have two numbers here. It's weird. Okay, so yeah, so I think that recently I just started syncing stuff recently in a repository. Okay, so I don't remember. Yeah, maybe I forgot to check the language. Yeah, so uh, what does this do? Non-negative. Okay, the digits are stored in reverse order, and each of the and each add the two numbers and return the sum as a linked list. Okay, so basically we do want to implement carry over. Yeah. Okay, so we add the first, we add the second. So if you add the carry, okay, so this should be easy in Python. That is okay. So first, what we want is Since we're just traversing the linked list, we can't have we can have an I iterator. So we just need so basically this is the head, right? So the cur one, so I'm not going to specify good variable name here. So let's just say this is a list node. Do we have reference in Go? Do we have reference? Reference. Do we have reference? So instead of a copy, we want to access the reference. Okay, no. So what about pointer? Okay, Go is fully, yeah. So even though garbage collection is bad for some languages, for Go it's very optimized. So yeah, unlike Python and JavaScript. Okay, so let's look at the first instance of reference. Okay, follows a pointer. Okay, follows a pointer, but no pointer arithmetic. Okay, that's good because stuff is a lot of stuff is dangerous in C and C++ because of pointer arithmetic. So you can have array overflows, array out of bounds, and stuff like that. So and okay, so you can mistake with nil pointer, but not background. Okay, so this is minus one foot gun. Okay, so neighbor. Okay, so for reference, okay, yeah, this is the word address, not reference. Okay, so the pointer, then we return the address. So that means, so this is garbage. Okay, so this is good because in C++, this would be not that easy because you return a temporary value from a function. So for an integer, you can just copy it. So there's no big cost. But for, let's say, you're going to return a big object or a big data structure, so you do want to mem-alloc that, to allocate that in the heap and then return the address. So since Go is garbage collected, we don't have to, yeah, we don't have to worry about freeing the value that gets this one. Go will take care of that, but the semantics are the same. We allocate a memory. I believe this is in the heap or this one is in the heap. I don't know. And then we return the reference. Okay, so this node. So I'm not sure if we can do this. So head one. Let's just say this the cur one or the current one, and then the L1. It points to itself. Oh wait, we forgot the var. Uh, we can just do something like this to make it simpler, but I want to be explicit with the type. So I'm not sure if this is going. Oh wait, I forgot. We have to do it the other way around. Okay, so my C and C++ skills will get in the way. So it points to L1 and L2. I'm not sure if I should put the reference or the address here like that. Anyway, let's try. If we get a syntax error, then uh that's good. Okay, unexpected. Okay, so maybe we don't need that. Maybe we do need to put that here. Expecting type. Okay, so that is a type. But okay, so we have a pointer. Okay, so we have the same declarations of Q. Where is Q used? Wow, Q is not used anywhere here. Oh wait, no. Uh, this is a return type. Yeah, so maybe we can look more for address. Okay, not much. Search for star. Um, follows a pointer. I'm I'm scared of double pointers. I'm scared that if we do this, we're not actually referring to the instance of the list node. Declared but not used. Yes, so we have to use that in Go. We have to use that in Go. Okay, so basically while cur1 has, so assume we have to assume that ano, okay, so we can be sure that, okay, yeah, no. Okay, so the length is not the same. Okay, so we have to check while cur1 or cur2. We don't have while, I forgot. Okay, so for how do we, instead of while, for infinite loop, but I want one with maybe we can do something like, we don't have the iterator, we don't have the, we do have the condition. Anyway, let's just say if cur1 is nil or cur2 is nil, then let's break. I hope Go will allow me to be explicit with the grouping, yeah, like this. And then let's see. So we also want to handle carry over, like carry. So that's an integer, and then that will be 0. And then while we have that, we have to get the two values. So we have val. Okay, so a, so var int a, a int will be the per one val. Another thing that's going to bother me for a long time is that I can't do snake case in Go, because the convention in Go is if you want a public attribute or variable, you have to do capital uppercase character first. If you want it private small character first. So no snake case. You can do snake case, but the convention, and we have to again follow the simplicity that is enforced by the simple semantics syntax of Go. So we add that if a I forgot what we're going to do. Sure. Enter the sum as a linked list. The sum is ito si Glenn. Hi, Boss Glenn. Shout out. Okay. Shout out kay Topper. Yan si Topper. Topper Herrera. Kay Boss Glenn. Ang master na QA namin. Yan. Okay. So the return is also a shout out also to Boss Angelo Cedric, the OPQA. And ngayon ay ano na, BA. Tama ba? BA? O tama, BA. Galing eh. QA to BA. And Antayin natin mag-comment yung OA. Alright. Na-shoutout ko na silang lahat. Galing no? May kailang... Ay, di, bawal pala. Bawal pala sabihin. Bawal pala i-announce yung secret project. I think. Alright. Anyway, we have to return also a linked list. Return the sum as a linked list. Yeah, not so we have a linked list. So bar result is also a list node. So this one is good because we're going to understand how to allocate or how to create an object. So to create an object or instantiate a class or a struct, that's I think the correct term. We do yeah, so we can do new. I believe make is for ranges and yeah, for a block of memory, so multiple values, basically a struct, but not entirely a struct, because if you just want an instance of a struct, you can use int new. And let's try new new and then date type. So this will be list node. But do we want a pointer? Do we want a pointer? So P here is not a pointer. Maybe it's a copy. The weird thing here is there's no Q, but Q will. Alright, so for now, let's set the okay, so we want to add A and B. So that is the result. So var res will be A plus B. Let's just simplify this because we're not going to use the value anywhere. So let's simplify this, and then we want to check if it exceeds 10 or if it has multiple values. So at max, logically, it should just only exceed to 2 digits because it's impossible to add 2 digits or two numbers that will have more than 2 digits in this case because we want the carryover. So at max 2. So to get the digit, we have to do mod. So our digit. So this is the last digit. So basically in wow. So Python Godbolt. Yeah. So basically, yeah, compiler explorer. Yeah, so basically we want to yes. Oh, it's saved. I was checking the performance or the resulting CP instruction doing basic if versus this ternary, which is just shorthand for this. So basically it's just the same, not much. But yeah. Okay, so let's try. So if our number is, let's say, 11, and then we can do print the div. We have this a b, so div mod of n by 10. So it returns the integer, the result, the quotient, I believe, and then the remainder. So a and b. So if we run this, uh, how do we run this? Uh, Output. Okay, so maybe using 11 is a bad is a bad example. So let's do 12. Okay, yeah. So this is the last digit, and this is what we are going to store. And this one is the like the carryover, like right. So if we just use 2, this will be 0. Okay. So this is the same if we just do print n over 10 and print n modulo 10. Yeah. So the quotient is the carry, and then the digit we're going to store is the result of when we do modulo. So digit, but do we have go div mod? But do we have that in Go? If not, we're just going to do 2 instructions. Okay. So this will be the digit that we're going to store. So this will be the rest divided by 10. And then the carry over will be the digit modulo by 10. Oh wait, no, it's the other way. It's the other way around. Carry will be digit, and then this will be the modulo. Okay, and then we're going to store that rest val to digit. Okay, and then so after this we also want to add here the digit and the carry. So like for the next iteration, if we have a carry, we want to add that. And then the carry should be reset. If we add a carry, the carry should be reset. Like for example, yeah, so we have this one. So I think so carry will be 0. And then for the next iteration, we want to say cur1 will be cur1 that next. So this one is where I'm skeptical will work. Then here we want to say return the rest. So be prepared for multiple syntax error. Yeah. As type precompiled list node. Okay, so response undefined has no filter. No val. Maybe we do need that. Okay, so there's no val. Type int has no field or method val. Because this became an integer, not of type list node. So how do we create an object? So rest like this. Yeah, type int. So rest became an int, not an object. So maybe we no, this is for allocating new. So go maybe let's getting started with generics. No, let's go with Thor. Thor, the god of thunder. And let's go basics, flow control, no. Yeah, more type structs. Um, let's say that, yeah, so it's a type, it's a struct. And then, oh, maybe we don't need to do this. Maybe we just, yeah, but the next one is a pointer. That's what I'm worried about. So maybe let's try pointers to struct. So so we can do vertex. So maybe we can do that because initially the value is 0, right? And then maybe not a pointer anymore. So this is weird. Oh, yeah, I forgot to say list node like this one. Yeah, too few values in struct literal. Okay, so we do have to make this. Uh, for now, let's just name this nil. Yeah, but still we have this one, which is an integer. Restable undefined type, it has no field or struct method val. But we do have that one here. Okay, but if we I see. Maybe we do have to put the ampersand there. Wow. Yeah, still not. Maybe let's try struct literals. Yeah. Okay, so we can has type. Okay, I think this is what we want. If that has type vertex. Has type vertex. So maybe we do want the address that is returned by this one. And it's good that we can reference the value here, like this. Cannot use list node value of a type precompiled list node. What does what does that mean? Now we're getting into the hard part. Okay, okay, so we do have to also be explicit. So this is good. Yeah, so this is good. This is enforced. Okay, so it's undefined here. Okay, so maybe if we're going to follow the where's that? Maps literal, mutating maps, exercise, method, interface. Yeah, no. Yeah, struct or pointers. Okay, so pointer is always an int, right? Because it points to the memory, generates a pointer to its operand. So I choose the pointer. Fish points to I. Okay, so points to J divide through the. Let's try doing this. So let's remove the rest. So yeah, this is still a, if we put a pointer here, cannot indirect list node value of type precompiled list node. Maybe we can do this, but let's do new. And let's try this one again. RESTful undefined type int has no field. So this becomes the rest becomes an integer. So uh how do we print the type? So we can be oh, we can print the type here because we're not going to see it in Leetcode. But let's try doing a per rest for the rest. And then this should be a like this one. Oh, I think I get it. Instead of maybe this one. This is what we need. So we need to dereference the pointer at the point. Type into no field or method val. So it still points to val. So maybe curres equals to the address of points to I. To rest, and then here let's do per rest. I don't know why it's not it's not or maybe I'm just not comprehending it well. But it should I'm not sure if I have this pre-notion that it should not be the same as how you do it in C and C++, but for some reason I guess it is. Okay, so maybe we're hitting the infinite loop here. So maybe this is not working because maybe this is not working because we're not actually getting the next list. So maybe we do need to put that here, and let's refresh so we can go past that. Okay, so let's run the code again. Okay, so yeah, so it's still the same error. Still the same. So this is weird. Why we can't why is it a allocates memory? Yeah, we want to allocate memory for list node. And then we don't use P at all. Struct fields. Okay, so let's just try list node. Maybe I should have proceeded with easier problems. Oh well, difficulties of learning a new language. Yeah, so maybe we're hitting the infinite loop. I'm not sure. So it shouldn't run for this long if there's an error. So maybe this is a internet connection problem. So let's refresh and then let's run the code again. Okay, yeah. So it's still the same. So we can't do cannot use stress variable of type precompiled list node as type because a we want a pointer. So can we maybe we should just do that. So it's returning a pointer that yeah. So we got progress in that, but this is what still bothering me. So 34. get in the request. Okay, so we still can't do that. This is not allowed. We're creating a, we're not allocating, so maybe this is just temporary. Yeah. So yeah, so we do need a new one here, the list node. So let's see what is the type of this as type. So this is what we expect, but if we do this, we're just returning precompiled list node. But if we remove that, then we are getting the type. So we are getting the correct type. So this means that res is a pointer to the list node. So if we want to access the value, it's either we do, so if we do a pointer to that, type int. So we don't want that to be an integer. Okay, so we're not hitting the while loop again. So let's just refresh. Let's just search for that. Golang create. Okay, so let's search for that one. And how to implement linked list, yeah. And now we're getting blank page. Static, yeah, we don't want static. Okay, so we have this. Oh, okay. No, wait, this is node. I see. So insert the interface. Okay, so if we want to access the list, p.next is equals to the list. Right, so if we want to get the next one, okay, so for example, here we have the list. So yeah, we got the head. Okay, so we just do p.next. Okay, so this works. And man, I hope tutorials are explicit instead of using this. So maybe if we're going to create a new node, we can do this. We can do that one. So instead of this, we do pointer and list node, something like that. Yeah. And then if we're going to give it a value, yeah. No, we're not. This is the new value, but we're not. List is not ref. Okay, so the next one will be this one. So let's see how we double link list. Okay, so let's try. So here we are allocating, and then okay, so maybe not this one. Okay, so we are allocating here. Then maybe, or I think, so since this is a, okay, let's read more pointers to maybe pointers to struct. Okay, so we created this one, and then we create a reference to access field exception struct point when we have the struct pointer p. So this is a pointer. I see. So this is what I was thinking before, like in C. But I thought that we don't have to do this anymore because like this has precedence over this one. So yeah, I was really thinking of writing it like this one before, but I thought that we don't have to because it's Go, not C. Because in C that's usual. Yeah. Okay, so but in this one, since P is a go to that one. Yeah, but it's still an int. So without oh wait, so the language permits us to write. Okay, so we can do that. Okay, so P refers to the reference, so we don't have a reference here. So I guess this should just work because this one, so here, this one, there's no pointers. Now, why is this an integer? That's not what I'm getting. So this is still a of type integer. This is still a type of type integer. That is not. But if we're just going to like the then pointer to rest, then let's do t here. This should work according to the example. According to the example, this should work. Undefined t. Like this one. Okay, okay, okay. I forgot that one. All right, so that works. So why is that? Um, let's do online go file. Let's analyze the types. Let's analyze the types so we can have a better understanding. So here, yeah, we have a um, playground here. So maybe uh, let's copy this one and then let's uncomment this one. And then this one, then this one as well. This one as well. Okay, so in Go, I believe even though the declaration is here, we can call it here like two numbers. So uh h1, h2. So h1 will be uh, list node like this one, then h2 list node. Yeah. So let's try running this. Okay, so we do have to pointer or no, not a pointer. Okay, so even in Go, you have to use what you import. So that's a good thing. So that is enforced as well. Okay, so we have a problem here that we should fix first. Variable type list node. Right, so it works, right? So there's no compiler errors. So let's see how we can print the types. Uh, type, print the type. How do we print the type? Print the type. How do we print the type? Learn types. Okay, here. So, but how do we print the type? How do we print the type? Okay, so maybe it's here. Variable, function, type inference, type conversions, na basic types. Uh, type T. Okay, so we can just do the type. What we have to do is fmt. Let's just paste this fmt format printf. So we want the type of res. We want to see the type of res. Okay, so let's rewrite imports and format. Okay, so we import that and then let's run it. Okay, so it is of type list node, right? But if we do this, okay, wait, let's print also the type of this one for T. So let's run this. Yeah, so this is a pointer. But if we write it like this, then we should remove this. Wow. Don't tell me. Tell me of an infinite loop. Okay, yeah. So that is a double pointer. Okay, so for now, let's how do we, yeah, that's how we do comments. Okay, how do we do comment? Okay, so the same as, okay, yeah. Okay, so it is a list node pointer. Yeah, so this is the same as this one. So we should be allowed to not do that. But for this one, I think this is where we need to get the internal undefined key, or let's do res. This should not work. So because it is of type T. So if we do the reference, yeah, so this is what I don't understand. Wait, is the stream updated? Yeah, it should be. It should be. Yeah, so it is of type int. So maybe what we should do is the reference. Oh, so that is weird. We could, don't tell me we have to do double pointer. Yeah. So if we do this, so now that is very weird. So error communicating with remote server. Cannot indirect res, variable of type int. Oh, So maybe this is really an issue. Maybe we can't really do this, but we have to have a like we have to now we can undo. Okay, so maybe yeah. So that is weird. So we really have to uh okay, so we should just return rest. I yeah. Okay, so that is weird. I don't know what's the problem. Okay, so we have the wrong answer, of course, because we're not creating a new one. So, so we have one. So I think for the next one is let's create a new uh list node. So t dot next will be a list node like this, and then the current key will be the t dot next, like like this. At least we're not hitting the infinite loop. Okay, so we cannot do this because it has to be a pointer. So maybe like this. Okay, so we have 77, 77. Okay, so we add 2, we got 7, then we add 2, so we have 0. And then we need uh so for the next one, we have 3 plus 4, so that should be 7. So we have 7, but it should be 8 because we have to add the carry. So I think we have a problem with the carry. Okay, it's 0, so the carry should be 1, right? So if we have 10, uh, let's open the Python compiler again. Python Godbolt. Okay, so Python Godbolt. Yeah, so we have here. Let's remove this. Okay, so if we have 10, it'll be 1 and 0. So the module is the digit, and the carryover is this, and then the carryover is this one. But the problem is, uh, when we carry over that, this should be, oh yeah, should be res. The result should be multiplied by 10. Okay, so this should be correct now. This should be correct now. Okay, so we have 8 and then we have 0 because of the last one. So we should check if we still okay. So we do that next, but basically what we want here is next. So we want to check for the next one if it is not equals to nil, and then so we have 0, 0. Okay, so the problem is this one. So if we're not sure if we still have, oh yeah, so because we're returning t to be the next one, but we're not sure if we're already finished. So we only want to go when we don't reach, yeah. So this is still weird. So in Go, does it mean that whenever we're going to access we have to create a, where is that? We have to create a pointer for that one. Yeah, so we create, so this one. So we create an object, and then we have to create this intermediary variable for to access that. So that is weird. So we can just directly access for the reference something. Mm, okay, so uh if okay, so I'm really I really got confused with that one. With the go semantics for that one. So if 7 and then 0 1, so 8, so we're at the end. So if um per one that, yeah, maybe let's just move this sweet with per one or per two. Basically, you can simplify this by just checking the next value instead of the current value. But I already named this that equals to nil. That equals to nil. Okay, so there you go. So we got accepted. So I'm pretty sure we're going to fail. We're going to fail some tests. Yeah, so in this one. So 8, 9, 18, 18, 18. So in this one, we reached the end of the list 2 node. So basically we already break. So maybe let's just break when both of them are nil. Okay, so invalid memory pointer, yeah. So we have this. So uh so v1 int will be 0, then var v2 int will be 0, and then if uh the current one is not equals to nil, v1 is equals to per1. That, well, do we have ternaries? Ternaries. No things, so maybe let's coalesce. Maybe uh, I don't think, yeah, I don't think we have one for coalesce because, yeah, nothing. Because that's not in line with Golang, like simplicity model or the author plus v2. Okay, so we have to handle that one. Okay, so we still have invalid memory address or near nil pointer dereference. So I wonder where that one where that came from. So okay, so this one. Okay, so basically we have to if per one that next, yeah, so it's not equals, yeah, so this would be simpler if we just handled the next one here, but uh let's just proceed with this one. Basically I think this should handle all the cases. So as you can see, this is not written properly. We can save a bunch of if statements by handling that here. Anyway, so we have out of memory. So why is that? Hmm. So why did we get that out of memory? So maybe this means that uh so this is weird. Why did we get this one? Why did we get this one? Cannot allocate block. Hmm. 4194 304. So let's see how big that is. So that's just 4 megabytes. I wonder why that failed. I wonder why that failed. I wonder why that failed. Cannot allocate. Go lang. Cannot allocate. That's weird. That's just a small. Oh, maybe there's something. Yeah. So maybe we're creating a bunch of garbage ones. So yeah. So we have a list nodes and then we have this one. And then why is it failing with list node? There's no value. Okay, let's check one. Let's check the one we have in. So this one we just, yeah. So this one we just have a true. So here yeah, we have here a coalescence check as well. So solve that value link here. And then we're basically checking here. Else break. Okay. Yeah, but the problem, I'm not sure if we're hitting, maybe we're hitting an infinite loop to the point that it created, it ran out of memory. Yeah, so if both are nil, so we're only going to get if current is not equals to nil. Okay, I think there's a point where we will that both of so this is basically a while true as well. So maybe instead of cur1, cur2 that next here, so we don't have to worry with this one. Cur1 that val. Yeah. No. I forgot that one of them could be null. So that's weird. Why are we getting that? In Leetcode, if we should get memory limit exceeded error for this kind of stuff. If we over allocate stuff, like we run into an infinite loop, and then for each iteration we're allocating memory. That's the time we should get that out of memory. But this one, we're just creating like 4 MB of memory. But we do have 4, 6, 9, 4, 3, 4, 3, 6, 8 bytes in use. So okay, so we're using around 500 MB already, so that is bad. Yeah, so maybe we're creating this one incorrectly. Uh, T that next. So the T, maybe we need to dereference. Yeah, but I don't think this is the problem. Yeah, yeah. So there's no issue with our. Yeah, so this one is wrong. Cannot allocate even in our. This one. So even in the simple case, we're hitting this error. So it has to be a link. So it has to be a pointer, right? So maybe let's try new list node will be this one, and then t that next will be, we point to that one. We'll point to that one instead. Yeah, so we have time limit exceeded. So for this one, so this is weird. We can just do shorthand for this one. So that's weird. Okay. So we're getting time limit exceeded because probably this is hitting an infinite loop because we're missing the break. So maybe what we want to do is, if our carryover is 0, if uh yeah, so at this point this is not maintainable anymore, so maybe we should uh rewrite this from the top. Yeah, let's try writing this from the top, so we can control more of what's happening, because at this point it's very unmaintainable. Okay, so given the knowledge that we gained when creating and referencing an object in the heap or a memory in the heap, or maybe it's in the stack, I don't know. So maybe we can have the result var result. So this is of type list node, and then we are creating this, right? So if we just do this, this should work, but we should get an wrong. Okay, yeah, wrong answer. So this works. So this is the same as doing this one. Okay. So now we know that creating an object and then the ref using ampersand will give us a pointer to that one. Okay, so let's do the for loop. So I think now we can also have this one, and then instead of creating temporary variables for the current L1 and L2 list node, since we're not going to return any of those, we can use we don't need the intermediary variables. So maybe we can do first, let's do the base check first. So if maybe L1 is not equals to nil, or maybe if L1 is equals to nil and the L2 is equals to nil, then we can break. Right, so maybe we can break now in the loop. So if we're still in the loop, we're still processing, then let's see. Instead of getting the values and then adding those at the end, what we can do is add them to the result now. Since this is addition, we don't have anything fancy to do. So yeah. So maybe we can do is result, but we need the current one. So we need to return this because this is the head. So if we're going to, since we're using linked list, we have to get to the next node. So we need a temporary variable like the current, and then this should be the same as result type. So this is the same type. So cur let's check for the L1 first if it exists. So if L1 is not equals to nil, then what we do is the current value plus equals to L1 dot value, right? So let's do the same one for the L2 per dot val is equals to L2 dot val. Okay, so for the carryover, um, for the carryover, we have var carry int will be the cur dot val. For the carry, we want to do the division by 10, right? So this will give us the carry one. So we need to define that here where carry 0. Yeah, let's just say carry. Okay, so if we have a carry, even if we don't have, let's just add that to the value. And then once we add that to the value, we have to create the next one for our result. So that will be current next. The next one will be var. Next will be pointer to the list node that we're going to create and list node. Yeah. And then the current one will be that end. Or yeah, list node and then pointer. So we need to also proceed to the next list for the L1 and L2. So I think we can do that here. So L1 goes to L1 dot next, and then L2 L2 dot next to save us some checking. So this should work, I think, or at least no syntax error. So let's try. Okay, so we have one. So we have to use capital one. Okay. So I guess using this convention, we don't have to add another keyword or other way to declare if a field or attribute is public or private in a struct. Okay, so cannot use list node value because, okay, yeah, we need to do this one. So if we already have this one, we can remove that. Okay, so output is 27. So we add everything in the, so we didn't proceed to the next one. So next. So we did not proceed. So we just add everything in that same value. So we did not proceed. So the next should be maybe, yeah, we do need to point to that. No, this is another syntax error, I believe. Yeah. So if we do this, so this is the same as this one. Okay, so maybe we can directly declare that here. Yes. Okay, so yeah. So the problem now is with the carry, I think, because the carry is not uh yeah, so if we do division, we get by 10, so 11 divided by 10 will be 1. 20 divided by 10 will be 2, so the carry will be 2. Yeah, I think we need the mod here. 11, so that will be 2. 2 divided by 10. Okay, so I forgot what do we need again for the Python bolt. For the digit, we do want the okay, so for the digit 1, 0, we do want the division. So since it's integer, I think it's implicitly converted or casted to integer. So there's no decimal. So if we only want to, oh yeah, so we forgot to handle the case that it exceeds this one. So we want carry, and then the actual digit will be carry val modulo 10. Okay, so in this case, if we just have 9, for example, uh, we're going to get that one. But if we have 10, then it should still give us 2, right? Yeah. So it should still give us 2. So the current value. Okay, so let's try putting that here. And then we're going to replace the current value with the actual digit instead. So for the next one, the carry. Okay, I don't think we need to do the carry here, but instead let's just do var carry int 0. Okay, so digit should also be declared as a proper variable. Okay, so we got wrong answer because 2 plus 5 is 7. So we work that did not work. So here L1 will be yeah, so L1 should be handled, and then yeah. Uh Maybe let's just simplify this one. So instead of doing this, we can just do, if the value is greater than 10, that means we have a 2 digits. So if cur.val is greater than or equals to 10, then we do the current.val will be the modulo, will be the digit. So this will be equals to cur.val modulo 10. So this one, if you modulo by 10, we get the last digit. So that is what we want. And then for this one, per that next will be, let's create a list node. But this one, we're going to give it a value, the next carry. So basically, this will be carry. But we already did that here. So var carry int will be cur.val over 10. So this will be carry. So otherwise, let's not create a node. So otherwise, so let's create a node here for the next one. Okay, so another, why do we get 4 here? Why do we get 4? Because I think, okay, so yeah, we're adding carry, and then if carry val is greater than or equals to 10, the carry.val over 10, so that will be 1. That will be the carry. And then the 2 is the digit that we want to save, right? So, oh yeah, so in this case, yeah, but it's only happening if we go past 10. So the current value is current value. So it's 7 modulo 10. So this should give us, this should still give us 7. Hey. So we're losing connection again. Uy, comment si Boss Eds, ang DevOps. Gusto ka na Boss Eds. Miss ka na namin. Yeah, so module 10 should still give us 7. So the value stored here should still be 7. But we're getting 4. Okay, so we're overwriting because we're not changing the current to the, to be the next node. Yeah, so that got us. Okay, so we got this one now again, but we have a excess 0 empty list because of here. So we should just also check before creating this one. We should also check for this one. So if else if this one is not equals to nil, but we're going oops, but we're going to reverse this one to or. So if in any case that one node is still can be traversed, we will still be create the next empty node. Yeah, so this should be okay. Yeah, okay, so we got accepted. So hopefully we get the correct. There you go. Okay, so compared with Python, so that is a big improvement in runtime and in memory. Okay, so finally we got finished with this one. Okay, so finally. Okay, so let's proceed with longest substring without repeating characters. Yung, nice. Okay na okay si Boss Eds. Okay, so I solved this one again in C# and not in Python. So I forgot that I did this one. Given a string S, find the length of the longest substring without repeating characters. Okay, so ABC, ABC, BP. So this one is only one. So basically what we want here is, so we don't want this with the we want this. So basically we can have like two loops, or maybe let's try doing a new approach. Go. Okay, so we return an int. So basically what I think we can do is we can use a double pointer, right? So a double pointer approach. So so for example, for A, B, C, A, B, C, B, B. So we will have two pointers, the left and the right pointer. So we will start here and then maybe here also. So usually for double pointer, we point that here. Okay. So since so we will also have a set or a dictionary. So maybe just a set. So a set. So an empty set. Okay, so we're going to check if the left pointer and the right pointer value. So at this point, this case, they're pointing at the same time. The same characters. So since they are, so if it is the same, then we will check if it is in the set. So if it's not in the set, we proceed. So the right pointer will point now here. So and then we will add a. So they're not the same. So we're going to increase C again, right? We're going to increase the right pointer here. So now, so the it's not the same with the left pointer. So we proceed here. So now the right pointer A is the same with the left pointer. And then if that's the case, we're going to check again with the set. So in this case, the character A is already in the set, right? So the value, so the current value, so let's track the result value. So this will be right pointer minus left pointer minus 1. So 4 minus 0 minus 1. So that will be 3. Okay. So since we got that, so we don't want to end. We don't want to end. So what we want to do is move the left pointer now to the right pointer. So the left pointer will now be here. And then we will clear the set. So we will do this again. So they are the same. So we will move here. So the right pointer will be here and it will be here. And then once we got here, we saw we saw that B is already there, so we add B, and then we see this one again, so we add B, so this is the same. Oh wait, this is already in the set. So once, okay, so maybe we're not going to check if the left and the right pointer is the same. We're going to check if the character is in the set already. So in this case, we should have add A, B, and then C, and then once we saw A, okay. So this one we already saw B, so this will be 3 again. So yeah, so I forgot that. So for the example, the PWWKEU, PPQ, PWW, and then we have KEW. So we have the rest here again, start at 0. Then we have the set here. So the left pointer, let's see, left pointer here, the right pointer here. So they should not be the same, right? So they should not be the same. So we will increase right pointer here. So we added P here, then it's not in the set, so we add W. So now we increase the right pointer. So since this one is already there, we're going to calculate. So 0, 1, 2 minus 0. So that will be 2. Okay, so I don't think we need the minus 1 anymore because this is offset by 1. So now we move the left pointer here, then the right pointer here. So we reset this. I mean, we clear this. Then we have K here. Yeah. So the answer, the answer is WKE. Okay, so we add W, then we add K, then we add E, then we saw W. So that is already here. So that will be 0, 1, 2, 3, 4. Oh yeah, because the right pointer is in the next duplicate. So we have to subtract by 1. So 0, 1, 2, 3, 4, 5 minus 0, 1, 2, 3. So that will be 5 minus 3, 0, 1, or 0. 0, 1, 2, 5 minus 2 will be 3 minus 1. So the leg is, oh wait, no. Yeah, no, yeah, this should be 1 and then this should be 2. Is that correct? No. Okay, so let's not subtract by 1. So this will be 2, this will be 3. Okay, so we are still not done because we can still find this, I guess. But I think we can just skip there, okay? So to do that, let's initialize our left pointer will be 0, and then our right pointer will be 0 as well. So for like this, so if L is greater than greater than or equals to the right pointer, yeah, then we should break. Then we also have a step. So this is good because we're now going to learn about step in Go. So we do have maps, variables. We do have variables, type conversion, constant, short variable, the variable with initializer. So let's see if Go has one for set. So Go set. All right, let's try Go. Okay, so it doesn't have a set data structure. Okay, so we can just use map as I thought. Okay, so maps. There you go, maps. So map, then the string. and then the value. Okay, so the declaration is kind of the type is not is kind of weird, but map. So we want a map, and the key is a car. Do we have car in Go? I mean character. Sure. Okay, so types, basic types, basic types. So what is the type for what is the type for so maybe byte is the type for a character, I guess. Okay, so let's try go lang car type. Maybe it's yeah, I think it's a byte because a character is a byte. Unless it's a Unicode character, then it will be the rune. Yeah, so byte is the ASCII character. Okay, so we should just do car and then the if it's already found, so that will be a pool. So let's return to the maps. Maps. Okay, so yeah, so map is like that one, and then we want to initialize that like this. Okay, so yeah, so we can do this in one line. So oh, we forgot to change this into a byte, and then we have to change this into a bool. Okay, so quick. So basically, if we or if we also want to break if else greater than or in this case r is greater than the length of the string. So how do we get the length of string? Uh, Golang length of string. The length of string would be just the len. Okay, so we can just do like in Python, like string and character list. You can get the length by using the len keyword. Okay, so greater than the length minus one because it's zero based. Okay, so we will break. Okay, so what we want to do is uh, if L is not equals, if L is equals to R, then we want to continue. We want to skip. So basically, we can just do this. We can initialize to one, but in the case that it's a single character, okay, so let's handle that. So in the case, maybe let's just wait for the to for the test cases to show that. But for now, yeah, let's not handle this. So if the string at the left is not equal to the string that is at the R, the right, so we go through each one, right? So then we also have to track of the maximum rest int equals to 0, and then we will return rest here. So we go to left and then we go to right, and then it's not equals. Okay, wait, I don't think we need a set anymore. We need a set. Okay, I don't. Okay, so I was wrong with the drawing explanation. Yeah, I think we don't need the set anymore because let's just say, let's do this again, PWWKEU. Because the left pointer, okay, yeah, we do need one because in this case, the left pointer is not here. Okay, so again, I'm wrong. So So the right pointer will basically go. So that means that the right pointer will is the only one we need to check, because if because the right pointer is the fast pointer. So if uh that's a right pointer, so how do we check if it is in a map literals exercise maps? uh Go check key in map. Okay, so basically we utilize the that in Go there's no try and catch and there's no exception, right? So if you get an error with something, it returns that it returns that. Okay, so okay, so if key exists. Oh yeah. Okay, so it yeah utilizes Go that the error is just a value. Error as value. So there's no try and catch, there's no exception like that. Okay, so it will not show unless you catch it, I guess. So if value, so actually we don't care about the value, we just want to check if it exists. So exist, and then we want to do is like this one. So I want to check if the s so this should be the set. Let's just call this the set. Okay, so if the SR is in the set, and then we do exist, so this is a one-liner. So this means that the key exists. So if the key exists, we want to say the rest will be the max, the max, I believe, of the current result, the current highest one that we're tracking, would be right minus L. So in this case, 0, 1, 2, 2 minus 0, 2 minus 1. Okay, so minus 1. So go lang math max. So instead of checking that if the current one is math max, okay, so small m for the module. Okay, so I don't think, I'm not sure if we need to import that or Leetcode does the importing behind the scenes, but yeah, so rest at max, and then then if we find one, we want to make the pointer, right? So we want to set the left pointer to the fast pointer, to the right pointer. So maybe we should have named this slow and fast pointer, because that's actually the algorithm, not the left and right pointer. So slow, fast, and then if slow is greater than or equals to fast, or fast and fast. So fast and then slow, and then the slow pointer will go to the fast pointer. Okay, so otherwise we just do fast as equals to 1. Okay, let's run the code and let's see. Okay, so as a type int, so basically you're telling me that 19, basically you're telling me that that max returns a float. Max, yeah, it returns a float. So we want to cast it into integer. So that will be casting, cast. So maybe here we have cast or convert, uh, coerce. Yeah, so maybe let's just try wrapping this in an integer. So what could go wrong, right? Okay, so now we can't use the parameter because max expects float, both of them to be float. So okay, so for this one, we're going to convert this into float 64. This is why I think uh, they wanted generics, so you can create your own math map. So this is kind of weird that we have to chalk. Okay, so for this one, expected tree, so we got uh because in the case that we forgot to add the character to the map, to the set. So to add a character to the set, we do uh okay, so the basic uh as fast is equals to true. Right, so we got one. So why is that? So we got A, so we got B, and then we got C. And then if it exists as fast. So the fast pointer increases by 1. So 0, 1, 2. And then the 3. So fast minus slow. So let's see. 0, 1. 0, 1, 2. Yeah, so the difference is 0, 1, 2. 4 minus 0. That will be 3. So it'll be 4 minus 1. Okay, so uh maybe the problem is with this one. So since we're casting, so maybe let's just skip rest with float 64 so we don't have to deal with casting anymore. So we don't have to deal with casting anymore, except for that one. For the slow and fast pointer. Okay, so let's try that one. And then for the return, let's do integer. Okay, so we still got this one. So let's see, where do we break? It already exists. We get the maximum. So we should fail at A, right? So let's comment this for one. So let's just assume, just say that it is 3. Yeah, so we got 3. So yeah, so the problem is with this one, I guess. So we're getting the maximum between fast that's slow minus 1, fast that's slow minus 1. So we got to A, so we want the next one to be maybe for this one, we got this. So we want to, yeah. So we want the slow to be with the fast one. And then, oh yeah. So when we got to the slow to the fast one, we want to say fast equals to fast uh, plus equals to 1. So basically, given this, we can just skip this and put that here since they are that is both common. Okay, so maybe something is wrong with the exist. Maybe something wrong is with the exist. All right, so the answer is A, B, C with the letter P. Something here and something. So if we remove this, let's try removing this. Let's see what will happen. So I'm not. So basically 0, right? Because we never reach the point that it exists in the map or in the map. A, B, C. So let's try with our Go Playground. Let's try debugging this one. Let's try debugging this one here and then let's just say uh, function main. Okay, so wait, is this the one we used earlier? Okay, so let's just say um of this one will be hello ABC. Okay, so let's try this one. We're going to okay, so this is not the one we used. Oh yeah, we have to use the the format. I forgot. The package mains. So that's weird. Okay, so we got this one. So let's see the uh let's see what's happening with our I think the line print line. Let's see what's happening with our I think the print. Okay, so like this. Okay, and then capital. Okay. So let's just print what's happening with our fast fast and low pointers. Go but failed. Okay, so the the directive is different from oh, you can do this from C. So for printing integer, I wonder what uh was the expected formatting. D is an int64. D is an int64. So why did this fail? Is this not in 64? We declare this as int. So maybe this or int 32. So what's the directive for int 32? Okay, so value is this. But here we have value the integer. So this is weird. Okay, so maybe let's just remove uh the directives, then just print as is. I hope they're not concatenated with a redundant new line. Okay, so print line doesn't need a new line at the end. Okay, so we have 4, 0, 5, 4, and then 6 and 7. Yeah, so this should, okay, so the problem is with the result. Okay, so the problem is with the result. So just as I thought, the problem is with the result. Oh, let's look at this. The problem is with the math map. Wait, no, there's no problem at all. There's no problem at all. Why do we get, huh, we did not get any 0 or 1. Maybe it's with the printing or result in here. So yeah, we expect int. So let's print the result here as well. Okay, so the result is still 3. So this is weird. Where's the issue with our, so this is weird. What's the issue with our, what's the issue with this one? They're the same. What? Now it works. What did I change? That is so weird. Anyway, let's run. Okay, so here we got 2 and then 3. So let's try this input. Okay, so let's see what we will get. So probably the problem is, yeah, so the result is 2. So 2, 0, because I don't think we need the -1 anymore. To remove the -1, that should give us 3. Oh wow. So we don't need -1 anymore. So let's submit that. Okay, so we got the output for with what? So we do need that one. Okay, so the problem probably is when we're dealing with okay, let's try again. So okay, so this they put, so we're supposed to get the duplicate at this one. So once we get that, so we move the fast pointer to 5, 0, 1, 2, 3. Okay, so let's, once we get the result, let's see where the fast uh, pointer is now. So this will be fast S1. So I think we need to do we need to adjust the slow because the fast points to the duplicate. The fast points to the duplicate. Okay, so here we go. We got 2, 0. Yeah, we got the result of 1 because of yeah, so this one. So 0, 1, 2 minus 1, so that will be 1. Yeah. And then the fast pointer becomes 3. So 0, 1, 2, 3. Yeah, so that is the problem. And then the slow point becomes 0, 1, 2. So that is correct. Actually, that is correct. 0, 1, 2. And then the fast pointer becomes 3. Then 3. So the next one, so we will check for this one next. So for this one, we should get 5. The fast pointer is 1, 2, 3, 4, 5. Then 2. So 2. So 5 minus 2. Uh, if we add 1 to the result, should that result is 3? But if we do this one, that should still give us the expected is 3, but the expected is 4. Okay, so what's the case that I'm not handling correctly? What's the case that I'm not handling correctly? Should we? Okay, so let's just finish this one, then let's stop with this one. So what's that one again? This one. Then let's remove the print statements. Okay. Okay, so and go, I think it's okay to have this. Okay, so you can't. So rest to, or let's just do rest and that should work. Yeah. And let's remove this one. And now we forgot the result. All right, so we got 2 and 3. So for this one it works, but for this one it doesn't work. So I believe what we can do is move the plus pointer -1. Yeah, so that's what we ex well, that's what we need. So we need to move the slow pointer by uh subtract by 1 because this case 0, 1, 2, 3. The fast pointer will already be in the W, so we want to be here. Yeah. And for empty string output, for empty string, I think we can just say if, or here, I guess, if the length of the S is equals to 1. I always muscle memory from Python's kicking in. Yeah. So let's submit. So the output is 0. So basically they are the same. Right, so in this case they are the same. So this is what I was talking about. So because we set the fast pointer to 1, that this case was not handled. So if we make that start at 0 as well, And maybe we should also check that the uh yeah, wait, no, yeah, we don't need that one. So, and we're getting a lot of wrong answers here. And oh, so this was last year. I did a C sharp last year. Okay, so in the case that we have A and A, in the case that we have A and A, okay, so connection problem is so we got 0, but the expected is 1. So maybe when we hit, so what did we hit here? So it's doing this, what do you call this? I forgot. I don't like that. So we have A and A. So starts at 0 and then 1. So we have 0 and 1. So 0 and 1. So we already got, so the first pointer is already, so this is not triggered. Let's do a negative one here. Let's try if we're hitting the, okay, so we're immediately hitting this because the fast is, oh yeah, so no, not this one, but we just added the, okay, so maybe initially we also need to add the slow pointer to true, because that's the part we forgot. We forgot to add the slow pointer. So now we got a wrong one now because we had the slow pointer. So the next time we saw it, so with this one, we don't need any more of subtraction. Yeah, so 341. So that is what we need. So we need to remove this, and then we need to add the, because the basically the slow pointer, uh we need to add that to the map as well, because that character is already checked, should be checked, I mean, or added to the set. Okay, so now we have B. So in this case, man, we need to handle a lot of cases. Okay, so for this one, the expected is 1, but we got 2. Okay, so why is that? So our slow pointer is B, yeah. So when we reach the the expected is 3, and then the expected here is 4. Expected here is 1, and the expected here is 2, is 1 as well. So since B is already added, and then we check the fast pointer, this one, so that already exists, so that will be uh, fast will already be 1 minus slow, and then so that will be 1 minus slow, so that will be 1, -1, so that will be 1, so the rest will be 1. So now we do slow is equals to fast, right? So that will be 0 again. But okay, so now we don't need this at all. Okay, there you go. Yeah, so we don't need this at all because we already handled the adding the slow pointer to that. So now we get this one because a plan as is equal. Okay, so let's handle this with single one so that is equals to 0, or then let's just return the len s. Then let's add more parentheses because I like to be explicit with the groupings. And there you go. Wait, did I not press submit? All right, so we have EU. So now Y, AU. So this should be 2. Yeah, so we have a lot of edge cases. -1. Let's make this -1 so we can track if we'll so we have -1 and 2. So A was added and then U was added. Okay, so basically we also need to check for the maximum here. If we hit the last one, we also need to check. It's basically we did not hit any this test, so we hit this case, so we break immediately. So we didn't set any rest because there's no duplicate. So for this one, we just need to uh, um, calculate the highest so far. So hopefully this covers everything. DBDF. So another one. Okay, so DBDF expects 3 and we got 2. So the problem with this one right now is so what's the problem with this one? Okay, so wait, we got a problem here. So the expected is actually the expected here is 3 as well. Okay, so um slow pointer is 0. We got that added to the set, that we go to D and then we add D. So that is already in the set. So 0, 1, 2 minus 0 will be 2. Oh, okay, because we need to check for BDF. So in this case, okay, yeah. So our algorithm was flawed because we don't want to make the slow pointer jump immediately to the right point to the fast pointer because we need to take this expression. So because that is a valid substring. So instead of slow going to fast, we need to just set slow is equals to we just need to increment the slow. So the pointer is already here, and then the slow will be already here. So in this case, we want to set that here, and then we want to set, then we want fast to stay as is. All right, so this should cover not everything again. So slow will be, we forgot to update our variables or the strings. Okay, so we forgot, so DBDF, so slow, fast. So the slow should be +1, but the fast. And then we need to clear the map. That's what we forgot. So go on clear map. So that is what we forgot to do. When we reach this, we want to clear the map. Reinitialized for loop with delete. So yeah, so I don't want, yeah, so let's do this because we just want to clear, not to let the garbage collector take care of that. So when we reach that one, the we want to okay, so what's happening? So it's weird. We have the undo button, but we don't have the redo button. So that's weird. So for okay in of the map, range of the map, we to set delete the set using the key. So this will be the set. Okay, so since we're in the new, okay, so for except for this one, for except for this one, because we read this, we already are in the ABC. Then once we reach A, we just go to B, and then the rest is mathematically at the B. Yeah, but the fast pointer is still the same. So in this case, okay, so yeah, for this one, but I think for this one's the issue. Uh, oh yeah, we forgot to, when we clear the map, we also want to set again the slow to true. Okay, so now we got 4 and then we got the 2. So the problem is now with fast pointer plus equals to 1. Okay, there we go. Now we got this. Now we got everything we want. So hopefully it handles all the cases. Like that. So let's submit. While writing. Okay, so the output is 4. The expected is okay. So the only expected is 3. So yeah. So we're still wrong with this one. So maybe we don't need this. I think we should, yeah, when we clear them up, we also want to add the fast again because we did, yeah, we forgot to do that. I think this one, then let's remove this one. This one. Okay, so plus minus equals to 1. Okay, not at all. So let's just set this. Okay, so what's the issue? So we clear them up and then we set the slow again. So we basically started here and then the fast is here again. So when fast see this in the next iteration, Yeah, I think we should increment before we add the past. Oh wait, no. No, now I get it. Now I get it. Now I get. Now I get it. Now I get it. The issue is uh because we're skipping what we should have already added to the map. So instead of going will be slow plus 1. So that is what we need. So that is what we need. There you go. Because the issue was uh, we cleared the map, but we forgot that the fast pointer is ahead. So since it's ahead, the characters it already gone through are not are cleared out of the set. So there you go. I did not expect to is this an easy one? A medium one, yes. So to take this long, but as you can see in the performance, the runtime that in terms of memory, it's like 1,000% lower. And then in the runtime, not much, but yeah, I think this can still be improved. Like uh, yeah. Okay, so I think yeah, let's just stop here. So I got too much go now. I have to go lang. All right.